So, questions from the homework from last day, X and Y intercepts, any of these you want me to go over? Now, if you didn't finish, this is a pretty important topic. You want to then, your homework from Monday is to finish this and get caught up, although I'm going to be doing another lesson today as well, but it's going to be a bit of a shorter one. I'm going to divide it into two parts. Any of these that you were going, hey, I have no idea how to get these. I gave you some nasties. Yes? 4E and 4G, I would love to. Oh, this is an application question. I think you found this graph went like this. And then what'd you get when you plugged in 1,000 right here? 200? And then what'd you get for 3,500? What'd you get for 5,000? Because I'll probably need those points. So when it's $1,000, we're 200 high. When it's $3,500, which is right here, we're 450 high, which is right there. You know what? It looks like we're actually doing this. Yes, Darian? Yeah. Okay. There is a pattern. Good. Can I connect this? $100 plus 10 cents per kilometer. Can you go 1 kilometer? Can you go? I don't know. We'll leave it for now. Which one are you asking? E? So use the formula to verify the answer in D. So let's do this one here. Now the formula it gave you is T equals 100 plus 0.1 times n, 0.10 times n, but I'm not going to write the 0. Yes? That's the equation. What does the letter T stand for, according to the question? Total cost. What does the letter N stand for? Ah! So if they give me a number with a kilometers next to it, like 2,000, I'm going to put it where the N is. I'm going to go like this. T equals, I'm going to rewrite the 100, I'm going to rewrite the plus, I'm going to rewrite the 0.1, but instead of an N, apparently they want me to do that. Which means I can now go to my calculator because T is by itself already. So now this is plug and chug. This is 100 plus 0.1 times 2,000. You know what? It's going to cost you $300 to go 2,000 kilometers. And I think if I look at my graph, 2,000 kilometers is $300. I'm right. Is that okay, Darian? Yep. So that's what you're going to also do for this second one here. Put a 4,500 in. Right there and crunch the numbers. Not only can I give you N, Amber, and say find T, I can also reverse the process. I can give you the total cost and say, how far can you go? Like in F. In F, they're giving me total cost in dollars. What that means is I'm going to go like this. 650 equals 100 plus 0.1 N. Right? Yeah? And now I'm going to get the N by itself. Oh, and remember when you're solving for equations, you reverse BEDMAS. So, how would I get the N by itself? By what? Okay? Except, you know what? I'm going to do that last. I reverse BEDMAS. I'm going to minus 100 first. Brody is correct. I have to do this first. Then I get 550 equals, and the 0.1 N just drops down like a domino. Now, Darian, how will I get the N by itself? Why divide, by the way? You're right. Why divide? And I always do the inverse or the opposite operation. So I'm going to go divide by 0.1, divide by 0.1. What is 550 divided by 0.1? Don't all rush for your calculators at once or anything. Or you should be able to technically do this in your head, but I'll live with it. I think isn't dividing by 0.1 the same as timesing by 10? It is, yes? If you got $650, Kira, you can drive 5,500 kilometers. Oh, that's using the formula F, I could have done it with the graph as well. So $650 on the graph is right here. When I drop down, is that $5,500? It is? Cool. I'm right. Darren, is that okay? Yeah. Any others? My gut feeling is a lot of the homework wasn't done. Now, I'm not just going to sit here and pause and say, well, you didn't do the homework, so you better do it now. I am going to say I'll still take questions on this on Monday, but I'm also making a mental note to myself, ooh, I'm putting some of these on your next test because maybe you all got the hang of it. That'd be great. I'm not so sure. Some of these weird ones, I would have expected some people to ask questions. I think they either didn't do it, or maybe you glanced at the answers and said, I get it. That could be. Going once, going twice. Yeah, Amy? 1D, love to. Did you try it? Yeah. Okay. What do they want me to find in 1D? The Y-intercept, which means I'm going to put a 0 in for the X. Okay? Amy, when I put a 0 in for the X, really what's going to happen is this. That's just going to vanish because it's going to be 0.5 times 0, which is just 0. My equation is going to be negative 2.4y plus 0.8 equals 0. And now I'm going to get the y by itself. How? Keeping in mind that when I'm equation solving, I do reverse BEDMAS. You're correct. I'm going to minus the 0.8 from both sides. Amy, that's going to have the negative 2.4y drop down. Do you mind 0 minus 0.8? I'm going to take a risk and do that in my head. I think that's just negative 0.8 because I'm running out of room. I didn't show my work. Sorry. How would I get the y by itself now? By? Careful, not by 2. Negative 2.4. Yeah. Y is going to be negative 0.8 divided by negative 2.4. What's a negative divided by a negative? So if this was multiple choice, I would cross out any negative answer because I'm a good test writer, yeah? And I think this is going to work out to 0.33333333333333333 or 1/3 as a fraction. Yep. Is that okay? Any others? 2D? This one here? So now it wants us to find the X-intercept, which means we're going to put a 0 in for y. What that's going to do is that's going to make this whole thing just vanish because 2 times 0 is 0 and minus 0 is just 0. Our equation is going to be 0.6x plus 0.5 equals 0. Yeah? How do I get the x by itself? Keeping in mind that I'm going to do reverse BEDMAS, trust me. Minus 0.5? When I do that, I'm going to get the 0.6x dropping down like a domino, and 0 take away 0.5 is just negative 0.5. Yep. Now what? By? Divide by 0.6, divide by 0.6. X is going to be negative 0.5 divided by 0.6, which I think is going to be negative 0.85666. Is that right? I'm going from memory here. Negative 0.5 divided by 0.6. 8 threes, Mr. Duick. Threes. I couldn't remember the fraction. What was it? 833. Is that okay? Yeah? Okay. If you have that done and you've understood it, hand it in. If you haven't, work on it this weekend. Ask me more questions on Monday. But we do have to move on a little bit, but only for a short part. Lesson 4. A hugely important concept, especially in Math 11 and 12. We're going to introduce it to you now. And we're going to test you on it a bit this year, domain and range. But it's going to get more important as you progress. Domain and range. 2 new words. Well, it says, use the chart below to represent the given relation in all the ways shown. So if I have a table that says -5 goes with 1, -3 goes with 3, 0 goes with 6, 3 goes with 9, and 5 goes with 11. First of all, as a list of ordered pairs, what we're really saying is -5, comma 1 is a point. -3, write this down, comma 3 is a point. 0, comma 6 is a point. 3, comma 9 is a point. 5, comma 11 is a point. 5 points on this graph. Can anybody see what we're doing mathematically? What turns a -5 into a 1, a -3 into a +3, a 0 into a 6, a 3 into a 9, and a 5 into an 11? Yeah? Sorry? So if I wanted to give the rule in words, I would say add 6 to come on, Mr. Duke, to the input. Yeah? Sure, that works. What would the graph look like? Now, we're going to have to do kind of a rough sketch here. I didn't give you proper graph paper. So let's see here. What's the biggest x value that I have? X value. Biggest x value? 5. What's the biggest, smallest x value that I have? I'm going to go -6, 6. I'm showing you, this is how you cheat when you don't have graph paper. I went a little bit bigger than my smallest and biggest numbers, and I picked even numbers on purpose because, Anthony, what's that right there then?
3.
Not quite 3. Right? -3? Oh, and what's that right there? 3? Yes? And now I can kind of eyeball each of these, divide them into thirds. I think it goes like this. Dunk, dunk. That's pretty close to dividing that into thirds. Yeah, I'm pretty good. For a freehand sketch, Jordan was as good as we're going to get. And I think I would go dunk, 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 dunk. That's pretty close to what we would get if we'd laid down a ruler and carefully measured every ½ centimeter or whatever. Yeah? Greg, what's the smallest y value that I get? What's the biggest y value that I get? You know what? I'm going to call this right here 12. How high? 6. How high? 3. How high? How high? Must be. I could put single hash marks, but I think it's going to be a bit crowded. So I'll live with that for now. So if I graph this, I get -5, -1. Sorry, -5, 1. Yeah, about there, ish. I can get 0, 6 bang on. -3, 3. -3, 3 about there. 3, 9 about there. 5, 11. 11, 5 about there. Oh, that's terrible. Without graph paper, that's about as good as I can get freehand. I won't ask you to do too much graphing without graph paper, once in a while. But in fact, if I'm asking you not to use graph paper, usually, Garrett, what I'll say is sketch instead of graph, because you're sketching it. What about as a mapping diagram? Now, for a mapping diagram, you would list all of your x values from smallest to biggest, -5, -3, 0, 3, and 5. You would list all of your y values from smallest to biggest, 1, 3, 6, 9, 11. And then you draw arrows connecting what became what. What did negative 5 become? What did negative 3 become? 0 became 6, 3 became 9, 5 became 11. What if I wanted to write this as an equation? The y value equals the x value plus 6. And then there's a box right underneath it. What it wants us to do is it wants us to circle whether this is a relation or a function. That's part of today's lesson, so hold on. You don't know how to do that yet. Okay. And then it says, what's the domain and what's the range? We're going to come back to that too. What we're going to talk about first is what is a function. So leave this blank for a second and turn the page. A function is a special type of relation. What's a relation? Any rule. What's a function? Specific type of rule. And here's what it has. For a relation to be a function, each element in the... Can you write the word domain and then in brackets put x? Each of your x values, the fancy word for x values is your domain, is related to exactly one element in the range. And in brackets, can you put a letter y? To illustrate this concept, to illustrate this, we're going to look at two relations described in words. For a domain, we're going to use the numbers 1, 4, 9, and 16. And for a range, we're going to use the numbers 1, 2, 3, and 4. And I'm going to give you two different relations, two different rules. The first rule is a multiple of. Is a multiple of. Here's what you would be asking yourself. Is 1 a multiple of 1? Yes. Is 4, let me get this right, Mr. Dewick. I'll complete the arrow diagrams. Is 4 a multiple of 1? Does 1 go into 4? Does 2 go into 4? Yeah? Does 3 go into 4? Does 4 go into 4? If I was doing this, I would connect that. Yoink. Let's look at the number 9. Does 1 go into 9? I would connect those guys. Does 2 go into 9? Does 3 go into 9? I would connect that. Does 4 go into 9? No. Let's look at the number 16. Does 1 go into 16? Yep. Does 2 go into 16? Does 3 go into 16? Nope. Does 4 go into 16? Yeah. Let's compare that with is the square of. Is 1 equal to 1 squared? Yep. Is 4 equal to 2 squared? Yep. What would 9 go with? What would 16 go with? It says complete the set of ordered pairs. So for the first one, I have 1 going with 1. Then I have 4 going with 1, 4 going with 2, and 4 going with 4. Yes? I have 9 going with 1, 9 going with 3. I have 16 going with 1, 16 going with 2, 16 going with 4. Those are all of the ordered pairs, Sam, that I can get from this mapping diagram. Compare that with the second one. I think I only have 4 points. I have 1 goes with 1, 4 goes with 2, 9 goes with 3, 16 goes with 4. Then it says plot the ordered pairs on the grid. We're going to put the range, that's your y values, on the y-axis. We're going to put the domain, that's your x values, on the x-axis. So 1, 1 works. 4, 1 works. 4, 2 works. 4, 4 works. 9, 1 works. 9, 3 works. 16, 1 works. 16, 2 works. And 16, 4 works. What about in this second graph? 1, 1 works. 4, 2 works. 9, 3 works. 16, 4 works. One of these graphs is a function. One of these graphs is not a function. I'm going to tell you how you can tell. Okay. Well, let's see. A function can only, Mr. Dewick, how about spelling it properly? Have a function can only have one y value for any x value. I'll show you what I mean in just a second. We'll zoom in, but write that down. A function can only have one y value for any x value. Take a look at this second graph. What's the y value that goes with x equals 4? What's the y value that goes with x equals 4 in the first graph? More than 1. 2, 1, or 2, or 4. This is not a function. Why is this one not a function? Because the x values have more than one y value. This is okay. One only has one y value, but here you got more than one, here you got more than one, here you got more than one. Graph 1, graph I, is not a function. Turn the page once you've written that down. Example 2 says, look at the following representations and state the domain, the range, and whether or not it's not a function. We're not going to do domain and range yet. That's going to be Monday's lesson. I just want to look at this and figure out function or not. I'll show you how you can tell. First of all, from a mapping diagram, you know it's not a function if one x value has more than one y value. I don't care if one y value has two arrows coming to it. That's okay. It's when an x value has more than one arrow leaving from it. What you're saying is you don't know how high that x value is. This is not a function. What about graph B? What about this table of values? Look closely. Do you see any x values appearing twice or any x values that are joined up with two different numbers? Brody? That is a function. What about this graph? Here's a point. I don't see any other x values that go with this point. I don't see any other x values that go with this point. We're good, we're good, we're good. In fact, you know what? C is a function, D is not. Can you see how I can tell, Garrett? See how this right here, when x equals -1, there's two different points at that height, two different heights? Function, not a function. Function, not a function. What about this table of values here? Now what I'm triggering on is I notice there's the same x appearing twice. That x value, does it go with two different y values or the same y value? Oh, sorry, I heard two different, I heard the same. Which one? It goes with 3 each time? This is still a function. Function. When you have a graph, Ben, there's a very easy way to tell. And this is why we prefer graphs. If you have a graph and you want to see if the same y value appears for more than one x value, there's an easy way to do it. It's called the vertical line test. In fact, we're going to underline this phrase, the vertical line test. And what it says, drag a vertical line, your pen, your finger, a ruler, my shadow for this arm. If you drag a vertical line across the graph, and if it hits more than one point at a time, the relation is not a function. Show you what I mean. Here's the vertical line, the shadow of my meter stick. Is that vertical line ever touching more than one point at the same time? It's a function. Let's compare that with here. Oh, right there. Not a function. Ashley, right here and right there fail the vertical line test. Not a function. What about here? Oh, if I draw a vertical line right there, is it touching the graph in more than one location at the same? Okay, so right now we have function, not. What about here? Well, let's see. If I run in this fourth graph, am I touching in more than one location at any one time? Big deal, Mr. Duke. Huge deal. I'll give you a basic one. Graphing calculators have a heck of a time graphing non-functions. In fact, most graphing calculators can't graph a circle. They don't know what to do. The computers don't know how to handle it. You need special software. Okay? So, let's go back to page 1. This little line right here. That red line, function or not? It is a function. And then I wrote here, homework sheet, identifying functions practice. Let me give that out. We'll walk through a couple of examples. That's going to be your homework today. We'll take a look at the sheet. Yeah, it's one of those lame joke sheets again. I called it identifying functions practice. It's got a front and a back. You have to figure out function or not. Now, when they give you points, what you're looking for is there an x coordinate that appears twice with two different y coordinates? Then it's not a function. When they give you a table, is there an x coordinate that appears twice with two different y coordinates? When they give you a graph, use the vertical line test. It's easy. For example, I'm pretty sure that's not a function. I can just tell with my finger in the shadow, right? Vertical line test works great. So for here, find the number of each relation that is a function at the bottom of the page, and then you'll cross out the letters. So for example, number 8 is a function because this one passes the vertical line test. So I find the number 8. I'm going to cross out that letter. And apparently, when you're done, you'll find what the baby porcupine said when it backed into a cactus, which you're dying to know. Turn the page, look at the back. Okay. So here, again, you have to decide function or not. If it is a function, for number 1, circle the letter A. If it's not a function, you'll circle the letter I. If number 13 is a function, you'll circle the letter G. If it's not a function, you'll circle the letter L. And the answer to the title question is found by reading the circled letters in the top row, then reading the circled letters in the bottom row. You should find out, what did Farmer John show his chicken when she wouldn't lay eggs? You're all dying to know. You got 20 minutes, and you know what? You need to finish the homework from last day, I suspect. That's also what you can do in the next 20 minutes. Vertical line test, what is a function? There it is.